Hello, and welcome to today's episode of On the Rocks. I am super excited about this episode because we are literally going to be talking about the crossover between mining engineering and bourbon. Today, as our guest, we've got Dr. Schafrik. Dr. Stephen Schafrik is the Associate Professor and Director of Graduate Studies for Mining Engineering and a Faculty Fellow of the James Beam Institute for Kentucky Spirits at the University of Kentucky. He is very active in SME, where he's the incoming chair of the Coal and Energy Division, the past chair of the Central Appalachia section, and founding secretary and treasurer of the Eastern Collegiate Mine Rescue Organization. His current funded research is in mine automation, technology for rare earth mining, and spirits maturation. With that, pour a glass and let's dive in. Steve, thank you so much for coming on the rocks today. There are very few guests that we have that are so perfectly suited to come on the rocks, so I'm really excited to have you on, and I know all of our listeners are really going to enjoy this episode. So to kick it off, you and I met at a Department of Energy workshop, actually focused on critical minerals just a few weeks ago, and we ended up talking about two of my favorite things, certainly, which are mining and bourbon. So could you tell us first a little bit about your background and how your work in mining has actually led you to help solve challenges within Kentucky's very famous bourbon industry?
Yeah, well, thank you. I really appreciated meeting you there, and actually your input into that meeting. You ran several of the discussions and things with the group. I think was very valuable, and just beyond our personal connection that we made there,
Yeah,
that was a really good meeting to go to.
it was.
And I
Kudos to
think that
our Department of Energy peeps out there. It was a super
yeah, they
productive
definitely did a
meeting.
great job organizing that. All the sessions were great in the breakout section. The what had happened. Obviously, I'm at the University of Kentucky now, and years ago, it became apparent to some of the people here at the university that there was a need to be servicing one of our largest industries, which is the spirits industry, in particular the bourbon industry, which is really centered here in Kentucky worldwide.
Mm-hmm.
Um, and so there was a few onesie twosies here and there, like people teaching classes and things, and we actually had quite a bit of our graduates going into that industry, but no organized center or institute around it. And so some of the innovative thinkers here in the university got together and really started organizing probably about 8 years ago or thereabouts. You'd have to ask Seth DeBolt and some of them that are running the James B. Beam Institute now about the infancy. But uh, fundamentally, what they were doing is trying to make sure that we're fulfilling the university's mission, which is supporting the industries in our state. Which obviously is one of the things that we do out of the mining engineering department is we're one of the few schools in the United
Yeah.
States that are producing engineers to go into mining. And when the institute was first being formed, BSI Beam Centauri came to the university with a large donation to found the institute, and so it was named after the founder of Beam Centauri, which of James Beam. So it's the James B. Beam Institute for Kentucky Spirits, where the idea is that it's a research institute that is feeding directly into classes so that students can get degrees and certificates. But you can't be teaching cutting edge stuff without doing the research to go along with it. And so, the two sort of started in parallel track. I really worked more on the research side. So one of the first things they did was have a big meeting with the bourbon industry and said, "Hey, bring us your problems. Like, just rant. Like, and we'll take some of the top researchers in the university, get them all together, get all you guys together, and talk about problems and possible solutions and what we can do as a university to help." And so I was actually expecting that we would be talking about fires because we generally don't think about the bourbon industry as being or the spirits industry in general as being a fire hazard, but it is. Like you can take what's stored in those barrels and pour them into your car and keep driving, right? Like, we're putting ethanol in gas. So, um, it, and then I came to find out, like when we were in the meeting, there's a major issue with corrosion inside of maturation warehouses, especially recently because they started making the maturation houses larger.
Mm.
Because the way of handling fires and some of the other incidents have improved quite a bit. And so the regulatory agencies have let them build bigger houses, started putting in bigger houses, and then all of a sudden, they're starting getting a corrosion problem.
So you're making me feel really good, Steve, just by the way that, like, of all the bourbon I drank, that I can, number one, pour it into my car, and number two, it creates corrosion issues.
Well, I mean, it's highly reactive, which is why we like it, right? Like, you know, so, and I'm not a medical doctor. I am at a school that is primarily a medical school, but, so since you can run your car on it, I reckon it's got energy in it.
That's true,
So,
right? Yeah, it's like
yeah.
a Celsius or a Red Bull. Yeah, exactly.
Right.
I'm just gonna start calling
Um,
bourbon my favorite energy drink now. Now that I have that line. Yeah.
Look, I'm not going to stop you, but I'm also not going to correct you. So we'll work out. It'll work out good.
Perfect.
Um, so I was sitting in this meeting and I'm going, well, you're having a sudden corrosion problem. I mean, have you guys tested the air? Like, what's the air like? And everybody went, you can't test the air. I was like, why not? I mean, like it's got to be flowing somewhere, right? Like there's some sort of airflow in these houses, right? Like I'd never been in a storage house,
Right.
a maturation house before, and they started explaining, oh yeah, well we changed the windows, we blah blah blah, it cross flows, all this sort of stuff, and I was like, yeah, but are you measuring it? And they're like, no, we can't measure it. It's a class 1 Div 1 explosive environment.
What?
Like we
That
don't have
sounds
we don't have the
like, or
well, it is.
does class one mean that it's not that explosive, so you don't have to measure it? They were saying like it's not.
Like they don't have the tools to do
Oh
it,
wow.
or they didn't have the tools to do it because you need to have intrinsically safe tools.
Oh, I see. Oh,
And I just went, well, I have the tools. I mean, it's,
yeah.
you know,
We measure it in mine.
I'll be there on Tuesday, guys. Like,
Yeah. That's awesome. Yeah.
you so that started some of my friends at Beam, and well, that's how we got to be friends. Is I drove out to a couple of their sites with pressure meters and anemometers and micromanometers and everything, and we just started doing, I mean, the equivalent of a PQ survey in the warehouses and going, okay, what do you think the air is doing, and let's look at what it's actually doing. And through that process, now, I mean, it did take a little bit to kind of figure out. It took like a solid 2 days of measuring things before we really figured out exactly what's going on. But what's going on is actually like mining stuff. Like it's regular to our technologies.
Yeah.
There's massive density separation happening in these warehouses.
Wow.
But you have to be thinking about those kind of things. Like, that's the basics of the simplest mineral processing there is, right?
Yes.
Is density separation. So even though it's a gas, it's doing that. The ethyl alcohol vapor is roughly twice, it's a little bit more, roughly twice as dense as regular air. What it devolves into is acetic acid. Acetic acid vapor is still roughly twice as dense as air. When you go into warehouses, especially warehouses that are having issues, when you're down in the basement area, the first floor, into the second floor, you can smell it. Like you smell it in the air, and as you move up in the house, the smell is less pronounced, and actually gets more humid because humid air is less dense than regular air.
Ah.
So inside of the barrel stack,
Mm-hmm.
there's no air movement for all intents and purposes. Whether there's barrels there or not, there's so much structure
Mm.
that it's got a really high high resistance to flow. So it's really high resistance tunnel. It's got nothing going on in there. It air separates, and you get more of the corrosive material. Ethyl alcohol is highly corrosive to steel.
Mm.
Um, you get more of it concentrated lower in the house, and it's it's not that big a deal when it's in the air. So as long as it would stay in the air, it would be fine.
Yeah.
But inside of this house, I've got all of these, 55 gallons of fluid um, that are surrounded by 1 inch of R8 insulation in
Mm.
the form of white oak,
Yeah.
and so it stays cooler than the regular air.
Okay.
Um, then we call these things houses, but I prefer to really think of them as tents
Mm.
because there is no air sealing whatsoever in these houses unless they're temperature controlling, and there's only a few places that do that.
Yeah.
Um, and so the barrel stays cold. The air temperature changes as the air temperature outside changes. You get a cold glass on a hot summer day. It gets condensation on it. Ethyl alcohol loves to mix with water. That's another reason why we love it so much.
Mm-hmm.
Um,
That's why we like the
and
rocks,
yeah, yeah, it mixes perfect, right?
right?
So it mixes, it condensates onto the barrels. That condensation is actually highly corrosive. It's corroding the bands on the hoops on the barrels, and that's where the corrosion problem's coming from.
So how long were they
Um,
seeing this issue, Steve, before they kind of were able to call you in? This must have been going on for a while.
it's been going on for a while.
Yeah.
Yeah, on the order of years.
And then you're like, you just need a big ass fan, basically. Is that what you or
Okay, well, I'll put in a plug for the Lexington based big ass fan.
that's what I was
That is a
thinking. Like
brand
I
of,
could just
yeah,
there's big
yeah,
ass fan
um,
company fans going around. Yeah.
right, and many of these, especially the palletized warehouses, so not the ricked warehouses, so where it's stored standing up.
Okay.
Um, Pretty much every one of those will have a set of big ass fans in it.
Mm-hmm.
And that's a different story that I'll get to in 1 second. Um, but no, I mean, I look at it from a mining perspective, right? Like
Mm-hmm.
if you have something bad in the air, you have two choices: you either tolerate it
Mm-hmm.
or you get rid of it.
Mm.
So my instinct is I teach ventilation.
Right.
My instinct is let's put in a fan and let's get rid of this stuff. But the issue is you don't want to pull air through because then you have air running over top of wood, and wood filled with fluid. You don't want to be drying it out, right? Like
Ah,
the angel share is a big issue.
interesting.
And actually, it's the source of a lot of contention around this particular issue because nobody wants to do anything that'll increase their angel share.
Hmm.
On top of, you don't want to do anything that affects the quality of the product
Right.
because who knows really the thousands of variables that are going into what is the quality of the product. Although actually, we have a couple projects looking into that.
Hmm.
So outside of the work that I do. So we are sort of we're looking at it from we started up by looking at it from what's the minimum amount that I need to get out of here
Mm-hmm.
in order to satisfy the keeping the environment normal.
Mm-hmm.
you know and again it's a density problem, so it's really I want to just it's a sort of the opposite of froth flotation, right, where we're floating the things up on the top is I just want to skim off the bottom.
Okay.
So it's actually more akin to radon abatement.
Interesting.
So we're putting in fans in basements of warehouses. We've developed a way of doing it that is stupid simple. We don't need to punch holes in the warehouse or anything, and we can use off the shelf things because we're not talking about huge amounts of air that we need to move. because we just want to gently pull that off. So effectively, what we're doing is pushing the basement down because we're doing everything off of pressure differentials. So I'm creating an area of negative pressure underneath the barrel stack. And so as the air is naturally separating,
Right.
whatever that natural process is, we're not
You're not going
affecting
to
that.
disrupt
We're,
that. Yeah.
right. What we're doing is we're giving it an area where it can continue to go.
Where it's not going to continue to corrode anything or, yeah.
Right. So instead of stacking up at the bottom, it's just leaving. So for all intents and purposes, we're putting 2 or 3 more stories on the in the building below the last storage of the barrels. So that density separation can happen in its own way, its own time. See, time's on our side. This is one of the things that's hard to understand in the spirits industry is you go through all this work and everything of putting all this stuff together. You pour it into that barrel. You go roll it into that warehouse, and you say, "Okay, I'll see you in 5 years."
Yeah. Hope it works out.
So. Yeah.
Yeah.
And that's been something that took me a long time to sort of wrap my head around because we're used to break something up on the face, throw it onto the conveyor, it goes on. It's sort of at most I want that thing hanging around like a month thereabouts, right? Like I don't want that thing in a stockpile forever,
Yep.
And their perspective, that's sort of flipped around. It's no. It has to sit in that stockpile so that it gets to be good stuff, in varying times and things. And by the way, while it's in there too, we don't want to mess with it. Like
right.
Nature does that.
No, I mean that's such an interesting conflict there because, like you said, you're trying to address one problem in one part of the system without disrupting all of the other parts of the system that you need to continue just as they are, right? I mean, it's a really interesting challenge.
Yeah, but again, totally common in the mining industry.
So what would be for folks that are listening, like what would be the mining equivalent of this problem? Like what would you see that you would be solving in a mine that would be so similar?
Well, that's a real good question. I look at it from the perspective of if we take any of our mining systems, so going from any of the mine to mill systems, all that sort of stuff. I look at these things as simple as if I'm trucking things over into my tailings and I want to switch it over into using a conveyor to go over into my tailings. That's an obvious, if you have enough stuff, if the economics of it work out, it's an obvious thing to want to do. But when you switch over from trucking to the conveyor, it doesn't just affect one thing. Now you have additional structures, you've got additional things, and all of those issues are going to be site specific. So you can say, here are guidelines that you would want to do for any particular site, but here at this site, it's going to be one thing or another.
Yeah.
So we're looking at it very much in the same sort of bend as from the bourbon industry's perspective. Just putting in a little simple ventilation system. Now I'm venting to the outside. That can affect some of my permits and those kind of things if they're not already in there. And so you have to think of everything as a system. So do I now need to have somebody who's checking on that fan?
Right.
Should I put that into my SCADA system? They do have quite complicated SCADA systems inside a lot of these.
And for people that don't know, what is a SCADA system?
Oh, sorry. That's well, I'll simplify it down. So your monitoring and automation systems, so any of your PLCs that you would have around that are monitoring sensors and then controlling them and reporting the values of those things out, that's your SCADA system. So your just data and control system going through your site.
Yeah.
In somebody's house, it would be as simple as their thermostat that has to turn on the heat and the air conditioning and it's measuring the temperature.
Kind of what people would think of as like the Internet of Things these days, right? How everything is connected and measured and censored. Yeah.
Right, and also a lot of these sites. So here's another parallel to the mining industry. A lot of bourbon sites are very remote, and they're very much by themselves. and they also kind of like it
Yeah.
that way. For a lot of the same sort of reasons that mining sites have liked it being that way.
Hmm.
Um, you know, so let me get back to one of the other, like, our other track that we've been taking. Oh, by the way, before I go off of the ventilation side of things, because the ventilation side has caused an additional complication, which I just touched on a second ago, which is air permits and things
Mm.
like that. So we can't everywhere be venting out of these warehouses for a variety of reasons.
Okay.
I'm not an environmental expert in this particular topic, so let's just leave it at that. But we can't always do it. So
We can't ever do
no,
everything we want anywhere. So yeah, that makes, yeah.
right. I mean, we're moving very little actual air
Mm.
anyway. But anyway, okay. So one of the challenges was, well, what do you do if you can't ventilate it? And so I've got two solutions to that as well. Now, I've got a little bit of a materials background, and so I've said, well, then let's start being able to tolerate it. Let's start being able to tolerate the rough environment. So I've been running a program out of materials engineering here at UK, also looking at different materials that could be used for the hoops on barrels, including plastics, which would be pretty wild, but I don't think anybody's going to go for the plastics, and in different coatings. So I've been running undergraduate student groups in materials, doing some of the long-term testing on that. It goes a lot slower than some of the things that I'm used to from the mining industry, because really we got to look at it long term over many years and inside of very, very changing conditions. So it's effectively outside, but it's not outside.
Yeah.
So we have accelerated corrosion things set up so that we can test things quickly, and then we have several coupon boards in warehouses around the state that are testing it long term as well. Then one of the other things that I'm doing, because that's also not necessarily the best solution at each place. Each distillery is really a lot like mine's, where they're following a overall sort of scheme, but every place is different.
Hmm.
And so we're also about to start deploying some what I've been calling filters,
Okay.
that are going to be able to absorb the ethyl alcohol and acetic acid out of the air preferentially.
Wow.
Um, and the challenge there was you can't do it. You can't use power. Um,
And why is
so I
that?
can't, like, just,
Just from a cost
well,
operations perspective, or?
from a cost perspective, it's hard to get a good idea of what 60,000 barrels of bourbon look like.
I would like to see it.
Um,
Yeah. I, yeah.
so
But I
you know,
understand. Yeah, it's got to be massive. Yeah.
yeah. So I mean, we're taking these buildings are 150 by 300 feet,
Wow. Okay.
and then 7 stories tall.
Whoa. Oh, I did not realize that.
So
Really, they're high. The way they stack. I mean, it's
yeah,
all. Yeah. Okay.
yeah. So I mean, 5 to 7. Okay,
Yeah.
again, very much like the mining industry, everything is really
Everything's
site
different.
specific. Um, yeah, so I make a terrible joke about a few years ago, right before the pandemic shutdowns, I'd been in about 3/4 of all the bourbon warehouses in Kentucky, and they're being built so fast. I've today, even with my continuing to go into new sites and everything, I've been in about a third of the bourbon warehouses in Kentucky.
Yeah.
Um, so they're all different,
Yeah.
and there's a lot of technology being developed inside of these things. And actually, I like to think that a lot of it's been developed in the work that we've done
Mm.
through the Beam Institute. So, some of this stuff might be new things to the mining industry as far as how we're applying mining technology to the bourbon industry. But I've been talking about this with every architect, everybody I can get my hands on, that calls me. I'll spend time with them and tell them, here's what we found. You know, it's sort of our mission, right, to make sure that all the barrels are saved.
Mm-hmm.
It's a safety issue. So then there's no secrets in bourbon safety.
Yeah. One thing that we talk about a lot on this podcast, and I mean, you and I spoke about it at the Department of Energy workshop. I mean, everybody talks about how can the mining industry kind of do a better job of being part of a community and being value add to a community, and how do you think outside the box as far as how you do that, right? And I just think this is such a cool way where that innovative collaboration with what you've done, how it, I would imagine, fosters greater collaboration, right? And how mining companies could kind of look at these relationships and leveraging this type of, networking to really be better, not necessarily better, but more involved in their community in a different way that really changes the perception of the industry and also changes the reality, right, of the value that the industry is bringing.
Yeah, so I like to think of it in the sort of terms of the work that I'm doing for the bourbon industry that's actually been a high impact work in the bourbon industry is a way of promoting the mining industry.
Mm.
Because what I'm saying is the technology that we use and that we've developed in the mining industry is supporting the bourbon industry.
Right.
So our value, it goes beyond our product. Like if you don't have a valuable product, you're not going to be in business. Like you're not going to be mining that rock
Mm-hmm.
if it doesn't have some inherent value. Um, but your value actually to the community isn't the development of that product.
Mm-hmm.
It isn't just your employees and that they're employed. It isn't just your taxes that you're paying, your real estate, your other taxes, all the other taxes. It's really the technology that you're bringing to the area. Because the workforce that you're developing in your mine sites are all really, really highly technical people. We get incredible electricians, incredible
Mm-hmm.
machinists, and mechanics that they can work on ginormous stuff.
Yeah.
you know, an F-350 that a normal mechanic would think is a huge truck is nothing to
Right.
them, right? And so I've sort of every time I talk about this with the mining industry, I sort of leave it with I think the lesson out of the work that I've been doing is really a challenge for everybody. That is, look at the stuff that you're doing on your mine site, and look at the kind of things your neighbors are doing,
Mm-hmm.
and your neighbor industries are doing. Because I guarantee you that there are places in the things that you're doing on your mine site that your neighbor could benefit from.
Yeah.
Not just the things you're making, but the processes, the technology that you're using, that you're developing. Even as simple as the systems approach that's been a lot of the things we've been talking about is things that other industries can really benefit from. And we need to be engaging with them at those levels in order to get them to stop, really like what we're doing.
Yeah.
That so that they go, oh, that mine over there, it's not just where I get my concrete.
Right.
It's where I got this know-how and that know-how. One of the things I said in a talk once is I went, okay, as a result of some of the work that I've been doing, I'm pretty sure if a law comes before the Kentucky State Legislature that poses some sort of trade-off between the bourbon industry and the mining industry, the bourbon industry is going to be going, wait a second,
Yeah.
we get value from the mining industry. And won't necessarily be going against it. Now, one of the later speakers, who's one of our experts on the politics of things, but you gave me a little bit of a correction on that. But I think the point's still valid. It may be a little bit overstated, but still.
No, but I think to your
you know,
point, we get so caught, or you hear a lot when you're around mining people, when you're in the bubble of just if it can't be grown, it must be mined, right? Like, people should value us because we make something that they need, right? And it comes across as very kind of like, well, if you don't like us, screw you, you're not going to have an iPhone, and that's not the way to get people to want to understand what you do and want to work with you. And it's kind of become a knee jerk reaction. I think that if we just keep trumpeting at people, how much metal you need to make a car or a phone or any of that, that they're going to wake up and say, yeah, we want to mine in our backyard, right? And that's not the case. But if they can see the value through these other collaborations, maybe they'll be more likely to be receptive.
Yeah, and well, I would refer your listeners to a earlier podcast of yours on space mining.
Mm-hmm.
It was a roundtable discussion, and you guys brought up that it just naturally, as part of the conversation, this always happens. Everybody started going, "Oh, well, we got Tang and whatnot from NASA." Right?
Yeah.
Like, so space exploration's been a value for those kind of things. Yeah, and I'm sure there'll be a link below.
Yeah.
And you're right about it, and actually, kudos to NASA. They're phenomenal at doing exactly what I'm talking about. Is going, okay, like the value in what we're doing isn't just putting heavy things into space.
Right.
It's the technology that we have to develop as a result of that is where our real value is, and people intrinsically know that, and every reporter on Earth loves writing those. Look at how awesome NASA is. You wouldn't have. I think one of my favorite examples from your podcast was Velcro. Right?
Yeah.
Like, they had to develop Velcro.
Yeah.
And actually, that was yours, I think. But we don't ever tell that same sort of story out of the mining industry, and we can. And the way that I know that we can is because I'm doing it right now.
Yeah.
Like, so I want everybody to start doing this. This is how I think this is how we really turn around the public perception of mining as being a negative thing. Because people inherently go, okay, well, whatever. I mean, I can do something else instead of my iPhone. I had something else before that.
Right.
There'll be something else after. The
super
will
smart
develop
people
something
out there.
else.
Yeah. No, I think
Yeah.
that's such a great point, and this would be a great challenge for us to put out to listeners and folks in the industry, because I actually don't know what the kind of Velcro equivalent or the freeze dried ice cream equivalent would be. That would be a great thing to look into. I'm sure maybe you've got a list of stuff other than what you've worked on, but I can't think of any off the top of my head, which I should be able to. I should be able to rattle that off.
Yeah, well, I have a list of things I've been doing.
Yeah.
At this point, and I do have a big wish list of things that I want to continue doing within collaborations between the mining industry and the bourbon industry. Like, we've been applying froth flotation technology to an issue of stillage, which is a problem not just for the bourbon industry, but also is a problem for beer.
Okay.
And other lesser malted spirits or whatever I forget the technical term.
Yeah.
So they are doing things at scale, right? InBev is huge. Beam Suntory is something like 80-90% of all spirits, all hard alcohol. Campari is a giant company that is producing a lot of stuff. They are like at our scale. They're highly automated where they can be. So I think the approach everybody needs to take is to really sort of sit down with their neighbors and get to know what they're doing in their industry and just listen, because especially in the mining business, everybody's a big problem solver.
Mm-hmm.
You have to be, because you're not just necessarily the fundraiser. You're also the chief engineer and the hydraulic mechanic and the chief janitor at times, right? So you just already sort of have that instinct, and it's just getting to know, like, what are they doing over there, and then you can sort of say, hey, like stillage in particular is one of my favorites. It never really occurred to me, the stillage issue, and also how much volume there is. But they're talking about stillage, and it's the remains from the beer making process, and it's this carbon that is in water at about the consistency of toothpaste, and it's never going to settle out. It sounded exactly like coal slurry,
Yeah.
like other. I mean, and I'm going, oh well, hey guys, here's how we handle that.
Yeah.
Like let's try it. Like let's take it through that process, and it's really just a matter of listening and then going, here's our approach. Let's try it.
I think that's a great thing to wave a magic wand and change about the industry, right? Would be first of all to listen more, right? And maybe exactly like what you all did with the bourbon industry at the university, like what are your issues, right? What are your problems? Asking your partners or your colleagues and fellow industries in the area, just starting from that position. We might be amazed at what we find out.
Yeah, it can be done.
Yeah. Well, thank you so much, Steve, for coming on. I have a feeling we're going to have a part two of this episode. So I really appreciate it. Maybe a live tour. Maybe we'll have to do an actual tour of some of this stuff. But thank you again so much. I really look forward to following up with you.